Please pause the video and try this question. Let's take a look. If x and y are positive numbers such that x plus y equals 1, what kind of positive numbers would add up to 1? Well, they both would need to be more than 0 because they're positive, and they add up to 1, so they'll both need to be less than 1. Right? As an example, maybe something like 0.1 plus 0.9, 0.2 plus 0.8, and so on. So x and y would both be between 0 and 1, and they add up to 1. All right. Which of the following could be the value of 100x plus 200y? So x plus y is 1, x and y are both between 0 and 1. Okay, and when I look at the three numbers here, 80, 140, and 199, one thing coming to my mind first off is, can this sum of 100x and 200y be less than 100? Because I'm thinking, even if I were to minimize this sum, in order to minimize the sum, I would make the value of y as small as I can, because y has a coefficient of 200, and I would make the value of x as big as I can, because x has the smaller coefficient, 100. So I'm thinking essentially numbers like, let's say, 0.9999, a number very close to 1, plus, and then y is 0.000. How many zeros do we need? 1, 2, 3, and then 1. There we go. So if these were the two numbers, then the overall sum would be 100 times 0.9999, which is 99.99, plus 200 times 0.001, which is 0 point something. So a very small number. So can the sum be less than this value? Think about it. As I make x smaller and y larger, the 200y component of the sum would keep getting bigger and bigger. So no, I can't go any smaller than this. Therefore, all these numbers, or rather the first one, 80, is too small. The sum has to be at least close to 99.9999. So anyway, at this stage, any answer choice that has 80 in it is eliminated. We're left with 2 only, 3 only, or both together. So we'll need to evaluate the other two numbers. Now I'm thinking in terms of the upper limit. I was thinking in terms of the lower limit earlier. Now I'm thinking in terms of the upper limit. So what's the highest value of 100x plus 200y given the constraints on x and y? So now I'm thinking I want to maximize the y value, the one which has the larger coefficient. So how about we now just reverse the numbers? How about x we take as 0.0001 and y we take as 0.9999? What happens in this case? Well, 100 times 0.001, that's still 0.01 plus 200 times 0.9999, that's 2 times 99.99, close to 200, right? Just a little bit less than 200, just a little bit less. So that's the upper limit. Can the sum ever go beyond 200? No, it can't go beyond 200, because for the sum to go beyond 200, we would need to get rid of this constraint of x plus y equal to 1. With that constraint in place, the highest possible value is when we minimize x and maximize y, and then the sum reaches close to 200. So can the sum be 199? Yeah, the sum can be close to 200. In fact, maybe we can come up with the exact values which would lead to this sum. So one way to think about the whole thing is 100. If I take common, I'm left with x plus 2y inside, and then x plus 2y. Remember, x plus y is 1. So I can rewrite this expression inside the brackets as this, and so I get 1 plus y inside. That's the sum, 100 times 1 plus y. So can the sum be 199? Sure. I just make y equal to 0.99. So 100 times 1.99 gives us 199. So the other two are both feasible. Similarly, if I were to also check, can I make the sum 140? Let's say 100 times 1 plus 0.4, that will give us a sum of 140. So as long as y is between 0 and 1, I will get feasible values for this sum. So essentially, the sum will be between 100 and 200. So the answer here is E.